Hey there, math puzzle masters. Today, we're going to tackle a kind of problem that looks a little tricky, but trust me, once you know the secret, it's actually super fun to solve. Let's get into it.
Okay, so here's our big puzzle for today. We've got 2 and 3/6 minus 1 and 4/6. Now, at first glance, it just looks like a normal subtraction problem, right? But wait a second. There's a sneaky little challenge hiding in there.
And there it is. See it? Look at the fractions. We have 3/6, and we need to take away 4/6. Whoa, hold on. How can you take away 4 pieces of a pizza if you only have 3 pieces to start with? That seems impossible, but trust me, it's not.
So, before we crack this puzzle, let's do a super quick review. What's a mixed number again? Well, it's just a number that has 2 parts smushed together. A whole number part, like that big number 2, and a fraction part, like our 3/6. They're just partners.
So, how are we going to solve our not enough pizza slices problem? Well, we've got a secret weapon. It's a special math tool, and it's called borrowing. This is such a cool trick. It lets us sort of rearrange our numbers so that we can subtract.
All right, here's our game plan. It's a simple 3-step mission. Step 1, we're going to compare those fractions. We got to see if the top one is smaller. Step 2, we'll use our borrowing magic and turn one whole into a fraction. And step 3, we subtract the fractions and then the whole numbers. Easy peasy.
Okay, puzzle solvers, let's get back to it. Our mission? 2 and 3/6 minus 1 and 4/6. We've got our 3-step plan, so let's put it into action. Okay, step 1, compare the fractions. We've got 3/6 on top and 4/6 on the bottom. Is 3 smaller than 4? Yep, it sure is. And that's our secret signal. It means it's time to borrow.
Now for step 2, the borrowing part. We look over at that big whole number, the 2. We're going to borrow 1 from it. So we just cross out that 2 and it becomes a 1. We've basically just grabbed one of those whole numbers to help out our fraction.
But what do we do with that one whole that we just borrowed? Well, we need to chop it up into fraction pieces. Think about it. If our pizza is cut into sixths, how many pieces are in one whole pizza? That's right, 6 out of 6. So, one whole is the same as 6/6. And here comes the really cool part. We take those new fraction pieces we just made, that's our 6/6, and we add them to the pieces we already had, the 3/6. So what's 6/6 plus 3/6? Well, 6 plus 3 is 9. So now we have 9/6.
So let's take a look. Before, our number was 2 and 3/6. And now, after a little bit of borrowing magic, it's 1 and 9/6. They look totally different, don't they? But here's the secret. They are the exact same amount. All we did was give it a makeover. We just renamed it.
Okay, on to our final step, step 3. Our new problem is 1 and 9/6 minus 1 and 4/6. Now let's look at those fractions. Can we take 4 away from 9? Yes, we can, absolutely. The problem is finally ready to solve.
Let's finish this thing. First, let's subtract the fractions. 9/6 minus 4/6, that leaves us with 5/6. Awesome. Now, the whole numbers. 1 minus 1 is 0. So we have no whole numbers left. Our final answer is just 5/6. We did it! Puzzle solved! You know, when you think about it, subtracting mixed numbers is really just like regular subtracting. The only trick is, if that fraction on top is too small, you just have to go next door to the whole number, borrow 1, and turn it into more fraction pieces. That's the whole secret right there. You guys did an absolutely amazing job with that one. You've learned the secret, you know the trick, and now it's your turn to be the puzzle solver. You ready for a challenge?
Okay, here it is. Your practice problem is 3 and 2/8 minus 1 and 5/8. This looks pretty familiar, doesn't it? It's just like the one we solved together. You totally know all the steps for this.
Okay, this is the part where you get to show what you know. Go ahead and pause right here and give it a try. And just to get you started, what's that very first step? What's the first thing you need to check when you look at this problem? You've got this. Good luck.